All right, so this is a 2018 question, but again, this one is not found in the notebook that you have, so you'll just have to either print or copy it from the sheet I sent you. So it is calculator active, just as another note. So number one, grain is being added to a silo. So right here, I kind of think of it as that in and out problem. I'm adding something already. At t equals 0, the silo is empty. There's that initial condition. The rate at which, so I'm going to catch that word rate, the rate at which grain is being added can be modeled by a differential function g of t, and it's measured in cubic feet per minute. So again, they're just confirming that's a rate with that per there. So use the data in the table to approximate g prime of 3, period. So we'll stop there. So if I want g prime of 3, I'm going to look for those two numbers that surround time 3. So I'm going to say that's g of 5 minus g of 1 all over 5 minus 1. And I'm going to throw those units down right away because I'm sure they're going to ask about it. The g of 5 would be 20.5 cubic feet per minute minus 15.1 cubic feet per minute divided by the 5 minus 1, which is measured in minutes. So I just want to be clear, I'm getting cubic feet per minute squared because I have this per minute per minute. I'm just going to grab my calculator. I think I get 1.35 feet cubed per minute squared. Now it says, of course, they're going to ask you this question. Using correct units, explain g prime of 3 in the context of the problem. So I'll talk a few things out. I took a derivative, so I'm probably going to start my sentence with the words, the rate. My answer was positive, so at some point I'll probably talk about increasing. And don't forget to talk about what the problem is about. So I'm going to go ahead and type mine out, and then you can compare. So again, I just want to stress I used the rate. And here's the context of the problem at which grain is being added to the silo. And here's what it's doing. It's increasing because that derivative was positive at this rate, and I have my units in there. Part B is super easy. Don't miss the first part. It does say write an integral, so let's make sure we do that. That represents the total amount of grain being added to the silo, and I believe they called that g of t. From t equals 0 to t equals 8, so I think that's pretty straightforward. 0 to 8 of g of t. Make sure you close it up with that dt. Now they want you to use a right. Just make sure you pick a right Riemann sum with 4 subintervals to approximate the integral. So again, it's not the actual area under the curve, not the actual answer, it's an approximation. So again, the x values are your base and the y values are your height. So I'm just thinking a right-handed rectangle. So up on the right, so the base is from 0 to 1. So that's a base of 1. And the height on the right is 15.1. Plus the next base is a base of 4 times 20.5, a base of 1, 18.3, base of 2, 22.7. And again, plug and chug in your calculator. I've got a 160.8. If I integrated cubic feet per minute, I took that rate away, and I'm just getting feet cubed. So all we've talked about now is that we started with nothing in the silo, and we added grain to it. So here comes in the next part. The grain is spoiling at a rate given here, where W of t is measured in cubic feet per minute. So again, I'm highlighting those units. Using the result from part B, approximate the amount of unspoiled grain remaining in the silo at t equals 8. So the first thing I had to talk about is the question is asking for unspoiled grain. So I'm going to write a function for unspoiled grain. So I have, again, it's this in and out question. The amount I start with, which was 0, plus the amount that came in, which was g of t, which was what was being added, minus the amount that went out. If it's spoiling, we're losing it. So minus that w of t dt. Okay, so from 0 to t. Now, I do need to go back and change these bounds because we said if that's from 0 to t, then these need to be x's. So I am just going to go back and change those. Okay, so I just want to talk about this again. This function here is my unspoiled grain measured in feet cubed, not a rate, so I don't want it to be per minute. That's why I'm integrating those two functions. And it just said at 8, use your answer from part B. So that's this integral that we just approximated, 0 to 8. It said use that answer from part B, which we just said was 160.8. Minus, I'm going to integrate this w of t in my calculator. Hopefully you've done that. I think I had like a 90, shucks, I didn't write this down. I feel like it was a 99.05 something. So I got a total answer of 61.748 feet cubed. Based on the model in part C, is the amount of unspoiled grain in the silo increasing or decreasing at t equals 6? Okay, so calculus-wise, increasing or decreasing are telling me to take a derivative. Now you don't have to guess the derivative of what? The unspoiled grain. Well, what did we just write that equation for? So let's go back and look. Our unspoiled grain started with nothing, plus the amount that came in, which was that g of x, minus the amount that came out, which was the w of x. And I want to know if this unspoiled grain here is increasing or decreasing. So I just need to take its derivative. 0 is gone. Second fundamental takes this upper bound and substitutes that in, times 1, minus w of t times 1. I'm saying times 1 from the derivative of the upper bound. And I'm just going to evaluate that at 6. And again, it's calculator active, so I'm just carefully typing that in my calculator. I think this was like an 18.3, which I'm just reading from the table, of course. 16.063 to leave me with a 2.236. And then make sure you answer the question. Since u prime of 6 is greater than 0, I would say that the amount of unspoiled grain is increasing.